atoms themselves don't actually move places. They're stuck in their place like bricks in the wall. They're stuck, but all they can do is vibrate a little bit and kind of push the other guy and letting him know or her know that there's energy coming from there. And that pushes him or her, and etc. Keeps going along the chain. Conduction happens by vibration of atoms. They pass on the energy, not necessarily by moving. Convection, on the other hand, the atoms are allowed to move. So, like in water, when you heat up water from the bottom, the atoms, what they do is, because they start to vibrate, they move apart. When you move the atoms apart, what happens? You get less dense, and less dense means you start to float up because the heavier stuff, the denser stuff sink down, and the heavier stuff float. So if we come back to that frying pan analogy, and you're heating it up from here, hopefully we can see that, and say the water's over here. What's going to happen is, as the heat energy reaches this section of the water here is going to get less dense, so it's going to rise. And what happens when it rises, it can't rise anymore, so it just travels along the surface, and it loses heat because the surface is only, 20, 30 degrees Celsius. So it's going to lose heat. As it loses heat, they start to fall back down, because when you lose heat, you get denser. And when it's denser, you start to sink, and all the lighter stuff start floating up. So you're going to get this circular flow, this circular motion. And these are called convection currents. Very important. Convection currents. We see this in water when we heat up water because the atoms are free to flow. We also see this in gas. So in the atmosphere, for example, you've got evaporation. You've learnt this in year 4, year 5, primary school. You've got evaporation, then condensation, and the cloud starts moving away. It starts moving inland, you know. So air goes up, goes this way, rains back down, and then it comes back. But imagine this now as the gas, not the water cycle itself. Very similar to that is you have the flow of wind. So air goes up, from hot surfaces it goes up, it travels across, and eventually it loses heat, falls back down. And then it just continues this cycle. When you think about the magma, the mantle itself, the inside of the earth is very hot, so the magma gets boiled, travels across the crust, and then it falls back down. And as it travels across the crust, you get the crust starts separating, and you get plate tectonics. Or sometimes they can actually, you know, on the other end over there, they move into each other. So you get earthquakes and a lot of volcanoes and things like this. So you get a lot of convection currents because the atoms are actually free to flow instead of vibrating and passing the heat upwards or sideways. Because the atoms themselves can move, they just move. It's so much easier to move if you can. That's convection currents. The third type of heat transfer that I want to talk to you about is called radiation. Radiation doesn't actually move heat, or the heat energy doesn't travel by moving atoms. So when we think about the sun and when we think about the earth, there's nothing in between. It's a vacuum. So when heat is coming from the sun, what is passing on? You've got no atoms between. So you can't have conduction, which is the vibration of atoms to pass on energy, heat energy. You can't have convection, so you can't have a free flow of atoms and then goes back to the sun and heats up, etc. You can't have that. So then we have to have a third type of heat transfer method, and that's just radiation. You're basically sending out massless bursts of energy. So you got your, gamma radiation, cosmic radiation, you've got your visible spectrum, just bursts of energy coming from the sun, and they can get trapped inside the atmosphere and heat us up. So radiation is basically no atoms, but bursts of energy, heat packets being sent towards you. So the best example is obviously the sun and the earth. Nothing in between, but there's bursts of energy coming in packets at the speed of light, mind you, because it has no mass. Because it has no mass, it travels at the speed of light, the fastest speed that's actually possible. So radiation is the third method of transfer which actually doesn't use any atoms at all, and it travels at the speed of light. So when the sun is sending us heat, it takes that radiation packet 8 minutes to hit the Earth. So if you're the Earth, you're going to have to actually wait 8 minutes to receive the heat packet that's created by the sun. You're going to have to wait 8 minutes for it to come. So if the sun switches off, it's going to take us 8 minutes to realize that the sun is actually off. So we're going to be there waiting 8 minutes, happy, living, and then suddenly it just goes black. But for 8 minutes, we will all still survive. So that's this lesson. It's the difference between heat and temperature. We've covered the difference. We've covered the scales, the 3 types of scales, Fahrenheit, Celsius, and kelvins. And we've covered the conduction, convection, and radiation methods for heat transfer. So what I want you to do now is listen to my instructions in the class that I'm about to give out, and write down your homework. I know, the best part of the day. Homework is 4.1 from the student book, and I'm going to say question 1 to 16. Let's do question 1 to 16. Thank you for listening.